In this video, we are going to discuss about the introduction to wafer to chip fabrication process flow. On completion of this topic, students will be able to provide the basic understanding on the semiconductor and to introduce the semiconductor process flow from wafer fabrication. So first one is CMOS fabrication. So this CMOS transistors are fabricated on silicon wafer. Normally the CMOS is nothing but complementary metal oxide semiconductor. This is the combination of both NMOS and PMOS transistors. NMOS is a N-type metal oxide semiconductor and PMOS is a P-type metal oxide semiconductor. N-type is a N-type of pentavalent impurities and P-type is the type of trivalent impurities doped on the semiconductor. So these three terminals are gate, source and drain. The doping is applied on the drain and the source terminals. And here we use the lithography process, which is similar to the printing press. On each step different materials are deposited or etched. So this is the easiest method to understand by weaving both the top and cross section of the wafer in a simplified manufactured process. So this transistors is used in various applications such as amplifiers, switching circuits, logic circuits, integrated circuit chips, microprocessor, and the major importance in the CMOS semiconductor technology is its low power dissipation and low operating currents. This manufacturing requires fewer steps while compared with the FET transistors. So here inverter cross-section, that is this doping will be used in the form of boron or metallurgy, that it typically use the P substrate for the NMOS transistors, and it also requires N-well for the body of the PMOS transistor. So it has a P substrate on which the N-type channel is created. As the name implies, this majority carriers participating in the current and the electrons. Also the movement of the electrons is fast while compared to the holes. And this P-well and the substrate tabs, this substrate must be tied to the ground and N-well to the VDD. So here it contains a metal to lightly doped semiconductor and forms poor connection, which we call it as Schottky diode, and it uses a heavily doped well and substrate contact steps. An inverter mask task, so this concentration will be having impurities which is applied as a crystals. So this can be chosen in the silicons with a clean and highly quantity of the semiconductors, which we call it as mask, and it has a cross section which is taken along with this dashed line. And this detailed mask views, it contains 6 masks. One is N-well, polysilicon, N plus diffusion, P plus diffusion, contact and metal. And the fabrication steps. So in this fabrication step, first step is processing the substrate. So the first step is to create the P-type substrate, and this P-type has a trivalent impurity such as boron with a concentration up to 1016, which this pure silicon wafer is selected on which type of P-type impurities, and they are applied as crystals. So this chosen wafer material is silicon because it is clean and high quality semiconductor material which is defined for the fabrication. So this can be started with a blank wafer, and we can build this inverter from the bottom up, and first step will be formed in the form of N-well, which covers the wafer with the protective layer. Remove the layer where the N-well should be built, and also this is doped into the exposed wafer which we call as a silicon dioxide. So the next one is silicon dioxide layer. It is made up of the materials which we call it as oxide. It has a stable structure which considered most abundant metal available on this earth. And the third one is photoresist material which is applied to the SiO2 layer. So in this region, the oxidation, this silicon grows on the top of the silicon wafer, and the silicon dioxide is covered with the photoresist material. It is a light sensitive material which forms a coating over the surface of the silicon layer. And this photoresist, after the photoresist is applied on the silicon dioxide layer, a mask with the desired pattern is used as a medium to expose those ultraviolet rays, and this ultraviolet light through the mask reaches the photoresist material and it remains on the surface so that the exposed part is removed from the surface. And lithography, this exposes the photoresist through the N-well mask and strip off the exposed photoresist. And etching, etching, the unexposed windows is removed from the surface and the regions are etched together to form a clean wafer surface. And here this seeks through the skin and eats the bone and only attacks oxide where resist has been exposed. And the strip photoresist, it remains as a photoresist. It uses a mixture of oxides. The remainings are formed from the wafer and the thin silicon dioxide is grown over the surface. This can be further added to the surface that forms the gate structure, which is deposited by the CVD process, and this has a high quality. And N-well, so in the N-well it is formed with the diffusion and ion implantation. It forms both diffusion and ion implantation. In diffusion, it places the wafer in the furnace and heat until it diffuses into the exposed assay. And ion implementation, the ions are blocked in the overexposed. And in the strip oxide, this is mainly due to the carried out to protect the S and D terminals, that is source and drain terminals, and also the oxide layer was removed from the surface to create the two terminals, that is strip over the remaining oxide, and which forms the back to bare wafer with the N-well. And in the polysilicon, it deposits very thin layer of the gate oxide, and the chemical wafer deposition of the silicon layer place wafer in the furnace, which forms the small crystals called polysilicon. And polysilicon patterning, here we use lithography process. And self-aligned process, here we use oxide and masking to expose the dopants. And N diffusion forms CMOS source drain and N-well contact. So this we can see the simplified design rules. And the inverter layout, so here the transistor dimensions of specific width length has a minimum size of 4 lambda by 2 lambda. Sometimes we call it as 1 unit, that is NMOS contains PMOS contains double the times of the NMOS. The overall summary is mass transistors are stock of gate oxide silicon. It can be viewed as electrically controlled switches. It pulled logic gates out of the switches and draw the mask to specify the layout of transistors. Now we can have everything necessary to start design a system and layout for a simple chip. Quiz questions. In CMOS technology, shallow P-well or N-well regions are formed using low pressure chemical wafer deposition, low energy sputtering, low temperature dry oxidation, low energy ion implantation. Thank you.